In the last video we looked at calculating the exact values for the sine, the cosine and the tangent of 30 degrees and 60 degrees. And in this video we're just going to finish this off by looking at 45 degrees. Okay, before we move on, I just want to make it clear that it's really important to understand where all of these values come from, how we've managed to derive all of these, and then they're not just plucked out of thin air. You will need to know all of these values. Okay, so when you do have a question in a test or an exam, you're not going to be given any of these values. You will need to know them, but it's really important to understand where they come from so that if you do forget them, you can always derive them yourself by using what we talked about in the last video in terms of the geometry and the SOHCAHTOA definition that we've learnt about previously. So with that in mind, let's have a look at the 45 degree angle. Okay, so here we've got an isosceles right angle triangle. Because it's an isosceles triangle, these two lengths are equal, and also these angles here must be 45 degrees each. We know that base angles in an isosceles triangle are equal. And like I said before, the lengths of these sides don't matter, okay? Because the sine of 45 degrees is exactly the same no matter what the size of the triangle is. So just to make things easy, I'm going to say that that length is 1 and that length is 1. Okay, and so how do we calculate the length of the hypotenuse in a right angle triangle? So hopefully you should be familiar with this, and hopefully you should remember that we can just use Pythagoras Theorem, which states that a squared plus b squared equals c squared, and we want to work out what this length of the hypotenuse is. So c squared is going to be a squared plus b squared. So a squared, so 1 squared is just 1, plus b squared, b is 1, so 1 squared again is 1. So c squared is 1 plus 1, therefore c squared is 2. So the length of the hypotenuse, we just square root both sides and we get c is the square root of 2. So this length here is the square root of 2, and now we've got all three angles and we've got all three side lengths. We can now calculate all of these trig values here. So the sine of 45 degrees first of all. And before I do this, I'm again going to write out our SOHCAHTOA definition up the top here. So SOHCAHTOA. So we know that the sine of an angle is the length of the opposite divided by the length of the hypotenuse. So the length of the opposite, so we've got two 45 degree angles here, but it doesn't matter which one we use because they're obviously the same, so we can just use that one there. So the opposite is 1 divided by the hypotenuse, which is 2. So it's 1 over root 2. And again, like I said in the previous video, we can leave it like this. This isn't incorrect, but it's much nicer if we rationalise the denominator. So to rationalise the denominator, we just multiply the top and bottom by root 2. So 1 times root 2 is root 2, and root 2 times root 2 is 2. So the sine of 45 degrees is root 2 over root 2. And again, I would encourage you to pause the video and have a go at calculating the cosine and the tangent. Okay, I'm assuming you've paused the video now. So let's have a look at the cosine of 45 degrees. So the cosine is the adjacent, which is 1, divided by the hypotenuse, which is root 2. And you can see that the sine of 45 degrees is exactly the same as the cosine of 45 degrees. Okay, so if we rationalise the denominator, we get root 2 over root 2. Okay, finally, let's look at the tangent of 45 degrees. So, again, we look at our SOHCAHTOA definition. Tangent is opposite over adjacent. So the opposite is 1. The adjacent is also 1, so it's just 1 over 1 or 1. So the tangent of 45 degrees is 1. Okay, so now we've looked at all of the different values for the ones in the box here, so 30 degrees, 45 degrees and 60 degrees. And like I said before, you will need to know these values, but there are some easy ways to remember them, so you don't have to remember every single one of these. Hopefully you spotted that there's a relationship between the sine of an angle and the cosine of an angle. So you can see here that the sine of 30 degrees is exactly the same as the cosine of 60 degrees. Likewise, the sine of 60 degrees is exactly the same as the cosine of 30 degrees. And what we just figured out also is the sine of 45 degrees is the same as the cosine of 45 degrees. And that relationship also holds true for 0 degrees and 90 degrees. So you only probably need to remember about half of these, and then you can deduce the other half based on that relationship between the sine and the cosine. Okay, so like I said, in a future video we're going to have a look at 0 degrees and 90 degrees. I hope you find that video useful, and I hope you enjoyed it.